You're never able to what?
Open the lecture and you record it.
In
Google
YouTube?
Email or wherever. I went to Google. That's when you put the.
Well, okay. There are two things. There are the lecture PDFs that are on the Google Drive.
Yes.
Those are the ones you couldn't open?
Well, I did that, but not the lecture that you recorded.
Right. The lectures are on YouTube. You click the other link for the lectures.
Well, I clicked and it went straight to the Gmail.
I'll check the link. It's supposed to be going to YouTube. All right, so I'll check on that. Thank you for letting me know. Okay, so we're actually picking up after our lecture from Wednesday. So we have here the zodiac, which is the menagerie, the zoo. It's the constellations that fall along the path that the sun takes. Now, is the sun really going around the earth? No. No. So when I say the path that the sun takes, what I mean is the path where we would see the sun going through the sky as viewed from Earth with the incorrect assumption that we're stationary. The fact is the Earth is the one that's traveling around that ecliptic, right?
Yeah. I was
okay.
trying to shake my watch.
So the whole signs of the zodiac, they're just constellations. There's nothing spooky about the signs of the zodiac. And your sign, in theory, is where the sun was when you were born. But as I mentioned in my first lecture, they changed the calendars by 10 or 11 days depending on where you were. But they didn't change the signs of the zodiac to correspond. So now, there's a 50% chance, well, it's probably better than 50% chance, but there's only a chance that the sun was in the constellation that matches your sign of the zodiac because of the shift. So as I said, when I was born, the sun was right about, okay, I'm going to change the color. Magenta. When I was born, the sun was right about there, and yet I have a sign of the zodiac that falls within there. Does it make any difference? No, because astrology is not a science. It's not based on any kind of reality as far as we know. It's just based on, well, let's see if I can make a really broad prediction. Today's going to be a good day if you were born in a year. I can already do this horoscope thing, right?
How much is that going to be?
I usually charge $5, but for you guys, I give the student discount of, $10. All right, so that's all the signs of the zodiac are. They're the constellations that we see the sun pass through. The path that the sun appears to take is called the ecliptic, and that's an important word. So the ecliptic, in reality, is the path the Earth takes around the sun, but it's what we see for the path the sun takes around the Earth. Now, oftentimes we think of the equator and get it confused with the ecliptic. So let me be clear. The equator on the Earth is the halfway point between the two poles. And the celestial equator is just going out from that. But it turns out that the Earth's axis of rotation does not correspond to the axis of orbit. You have a question? No. Axis of orbit around the sun. In fact, the Earth's axis is tilted 23.5 degrees from the axis of its orbit around the sun. So that means that the Earth's equator does not point at the ecliptic at all. It's tilted 23.5 degrees. So we'll see coming up lots of pictures where we always draw the Earth like this to illustrate that 23.5 degree tilt. And so the Earth's equator, and thus the celestial equator, is along this plane. Whereas the sun falls along this plane. And that is the sole reason. Oh, wait, I shouldn't tell you that's the sole reason because it's going to come up as a clicker question sometime soon. Whoops. Well, we got that one covered in advance. As we go around the sun, we see the sun appearing in different constellations, and we see the sun moving compared to our equator, north and south, because of that 23.5 degree tilt. And it repeats every year, so we call it the annual motion. Once per year. So here you see a picture just like what I drew, right?
Oh, that looks exactly the same.
Thank you. Thank you very much. So you see the 23.5 degree angle is the angle right here. They show the arrow on one side, the arrow on the other, and the angle is the angle between the tips of those two arrows. Just in case it's confusing how they draw it. And so if you look at this, we can think of the Earth getting lit up by the sun, the same as we thought of the moon getting lit up by the sun. One half of the Earth is always lit up by the sun, the other half is not. And so what do we call it if you're on the part of the Earth where you're getting lit up by the sun?
It's
Daytime. So it's daytime on half the Earth, but if you look here, you see that it's 23.5 degrees from this vertical line to where the pole is. In this position, the North Pole is never going to see daytime. In other words, that's the long night if you're at the North Pole. Because you go many, many days, and it depends on your latitude how many days it is, without seeing the sun.
That's winter for us here.
That would be winter in the Northern Hemisphere. And it's coming up, but the reason it's winter in the Northern Hemisphere is twofold. Reason number one is we go into shadow and spend more time in shadow than we do in sunlight. Right? Because we are in this portion here that sees the sun go down before you've gone halfway. So we have less time in sunlight, more time in shadow. We get heating from the sun, so less time in sunlight, less heating. The second one is the angle. The sun, we're about 40 degrees north. So here's the Earth. Here's the equator here. We're about 40 degrees north, so we're something like this, right? Now, the sun goes between 23.5 north to 23.5 south. And at this point, the sun is down here at the southmost point. And so the angle from where we are to where the sun is the biggest it gets. Which means we're seeing glancing sunlight instead of like direct sunlight. The farther away it is from overhead, the less intense the radiation is going to be. So we're getting less intense radiation and for less time. Hence, cooling effect. And the reverse is true if you were in the southern hemisphere at that self-same time. Notice the South Pole never has the sun set, because the South Pole is going to be right there. So it's not going to have the sun set. It's going to have constant sunlight. Now, the South Pole is not, it's still going to be fairly glancing. But if you were somewhere like the Tropic of Capricorn, I get north and south confused. Cancer and Capricorn, I think Cancer is the northern and Capricorn is the southern. If you're at the Tropic of Capricorn, the sun would be directly overhead, and you would be getting, the most intense radiation possible. And in the southern hemisphere, you're getting more intense than average and longer days, so it would be summer. So when we have winter in the northern hemisphere, what do they have in the summer? Yes, in the southern hemisphere, they're having summer. I meant to say, what do they have in the southern, and instead I gave the answer, what do they have? All right. A very key thing to remember is this 23.5 degrees. It comes up over and over and over as we go through this geometry stuff on what makes the seasons. So here is a picture trying to illustrate, once again, the celestial equator versus the ecliptic. And you see that's, once again, just like what I drew, just, written by somebody else. It's more artistic. We have some important terms. Solstice. The solstice is when the sun is at its extreme point. So the summer solstice is going to be when the sun is the farthest north if you're in the northern hemisphere. The winter solstice will be when the sun is the farthest south if you're in the northern hemisphere. And of course, when you're in the southern hemisphere, you'd reverse those. And so these solstices come at specific dates. Summer solstice comes about June 21 or 20. The winter solstice comes about December 21. Interesting, the winter solstice is generally these days considered the beginning of the new year. And so if you are a pagan, you might go and celebrate the winter solstice. I think they call it Festivus. Of course, I'm a Christian, and Christians celebrate the pagan holiday that's been Christianized and now called Christmas.
Yay, Constantine.
Okay. Christmas, as you might have guessed, was a pagan holiday for the New Year. New Year's, of course, is another day we celebrate with football, and it's also the New Year. So we really have 3 dates that, depending on who you are, you might celebrate the New Year on. Now, which one is very technically, that's by astronomy, the New Year of those?
The solstice.
The solstices. Yeah. The others are because of the vagaries of changing the calendar over time, not technically at that New Year point. Now, something you may not know. Well, first of all, you probably do know. Seventh-day Adventist Church came out of the Millerite movement, right?
Yeah.
And the Millerite movement wasn't William Miller's idea, but eventually he adopted that Christ was to come on October 22, right, 1844. What's special about October 22?
It's a solstice. It's an equinox.
It wasn't, but...
It wasn't then.
Yeah, but it wasn't then. But Bishop Ussher, in Ussher's chronology, you probably all know about Ussher's chronology, where he goes through and looks at the genealogies of people who lived in the Bible. And Adam lived X number of years and beget Seth, and Seth lived X number of years and beget Enos, and so on. And then there's also important events like, and from this time to this time, it was so many years. He used that kind of information, doing very detailed and exhaustive work. His annals, I think it's Annals of Time or something like that. It's a huge, huge thing. But he calculated very carefully the best reckoning. Now, there are minor quibbles you can make, but best reckoning for the beginning of Adam's aging. And he went a step further and he said, now, the Hebrews traditionally started the new year at the equinox. And so he calculated where the equinox should have been, based on the calendar of his day, and he came up with October 23 would have been the start of the new year, and he said that must have been when the creation event, the start of the new year, so that they would just keep their years counting from that starting point. So October 22 would have been the last day of the year as described by Ussher. Kind of interesting, isn't it?
That's pretty cool.
Okay, so the solstices are when the sun are at its furthest north and furthest south. If we're 40 degrees north and the sun goes as far as 23.5 degrees north, why 23.5 degrees? Because we're tilted 23.5 degrees. Then that means the closest the sun gets to overhead is 40 minus 23.5, which 40 degrees minus 23.5 degrees is equal to 16.5 degrees. So the sun gets as close as 16.5 degrees away from overhead. But then when the sun is on the other side, when it is the winter solstice, it's going to be, and I better draw some pictures. I actually drew a picture like this a minute ago, but I wasn't thinking to keep it. So here we are. When the sun is at its northernmost point, this is 23.5 degrees, and this is 40 degrees. So you take the difference between 23.5 and 40, and that tells you the angle between overhead and the sun. But when the sun is as far south as it goes, it's going to be down here at 23.5 degrees. And so, yes, we had, the 40 degrees went from to here. So it'd be 40 plus 23.5, so it'd be 63.5 degrees. And that's a pretty far distance from overhead, right? Since the horizon is at 90 degrees, then the sun at this point is going to be 16.5 degrees above the horizon. So that's pretty low. It doesn't get very high in the sky in the middle of the winter here. Was that?
Oh, I was confused on that, but then I got it.
Okay, good. Now the equinoxes are these points where the ecliptic meets the equator, the celestial equator and the ecliptic cross. Then the sun is right over the equator, and so its equinox, in theory, your day would be equal in length anywhere on Earth. It's not really, but in theory, it would be. Hence the equinox. Now, the equinox can be located as both a time or a position, just like the solstice can be either a time or a position. So the equinoxes, here it says in March, that's going to be like March 21, and over here it's going to be like Mom's birthday, September 22. I can actually remember that one there because it's my mom's birthday.
Nice.
Now, what's special about these, and I don't think I have a table, so I'm going to write a quick table. The winter solstice is December 21, roughly. They can vary by a day or so. Then we have the June. So those are rough dates for them. Those mark the beginnings of the seasons. So what season begins at the winter solstice? This one's a toughie.
Oh, man. Winter.
Nailed it. So it's winter from the solstice to the equinox. Then what's it going to be from the, I wrote spring here, so from the spring equinox to the summer solstice?
Rain.
Not tough. From the summer solstice to the autumnal summer. And then it will be autumn.
Doesn't it get like super cold before December 21?
Okay, that is a clicker question coming up. So, oh wait, you can't see the clicker question. It's available for you to answer, but I do need to make it so you can see it. Oh, whoa, whoa, whoa.
You can just tell us the answer and we'll click that.
It's
What channel are we?
33. There it is. The winter solstice occurs on December 21. What is the coldest month in the northern hemisphere?
Oh.
I mean, in theory or really?
In reality.
Yes. I'm guessing.
It's not trick.
They're all cold.
Whoever is B8FF68. Need to figure out who that is.
Has that person got it right?
Huh? Oh, I don't know if they got it right or not. I just know they answered and they're not registered as one of the students. Okay, give it another 10 seconds here. I can narrow it down to Holly, Sarah, or Margaret. It's yours? Okay. Okay, so that means Margaret, you're the only one that doesn't have one, right?
I checked this morning. I called their
They don't have them at the bookstores?
Yes,
Sorry.
they don't.
Okay. Okay, the answers we got were 0, 2, 7, 2, 1. Okay, so we have essentially a bell curve there with the majority, 2, 4, yep. The majority said January. The truth is, these 2 months are the coldest. I would have accepted either one as being the coldest. But that takes us to the question that Lauren Lee asked. If we get the least radiation on December 21, shouldn't December be the coldest? And the key is the Earth never reaches really equilibrium in temperature. We have heating from the sun and we have cooling from radiation leaving us. And when we're receiving more radiation coming in than we emit, we're going to be heating up. When we're receiving less than we emit, we're going to be cooling down. So on December 21, we're receiving the least, but we're still emitting more than we receive. And even though the amount we receive is going to start picking up thereafter, we're still emitting more than we're receiving, so we're still cooling down. And it's not until you get to February that you start receiving more radiation than you're emitting. And it starts warming up again. So there's a delay there because we're not in equilibrium. Does that make sense? Okay, now let's see what I skipped to get to your question. I have become a very slow lecturer, it turns out. Question?
Can you go back to the thing with the dates for the equinoxes? It's right there.
Was it on that as well? Here's where I had written them.
Okay.
But that will be on the...
It's in the textbook and everything, yeah. Are you good, Cecile? Should I move forward? Or?
Yes.
And like I said, there's like a plus or minus a day or so on most of those. The only one, even the first one, because if you have leap year, it shifts it by a day. So there's some variations. So now, this here is on what makes the seasons. There are some people that believe we have summer because the earth must be closer to the sun. Now, that is very easy to logically refute. If we had summer because the earth was closest to the sun, then it would be summer everywhere on earth at the same time. But it's summer in the northern hemisphere when it's winter in the southern. So that just can't be it. Furthermore, we can actually measure the distance from the earth to the sun, and the earth has what we call perihelion when it's closest to the sun, like January 5. Actually, I think it's moved to January 4, but January 5 was an ex-girlfriend's birthday. I remember it. My wife gets very angry when I remember her, though, so I try not to. I know, doesn't make any sense. It's not like I'm dating her or anything. So we are closest to the sun in the middle of our winter in the northern hemisphere. Now that does make an effect. We're going to have slightly milder winters because we're closest to the sun in the middle of our winter. What about in Australia? They're in the middle of the summer on like January 4, January 5, so what's that going to do to their summers? They're going to make it a little hotter down there. So the southern hemisphere summer is going to be a little hotter. The southern hemisphere winter is a little colder, but it's going to be a little milder in the northern hemisphere. That actually makes a difference to the global climates. The global climates, the time when the earth is closer to the sun is going to affect how strong the seasons are, and from that, general trends of warming and cooling for the globe. And the time when we are closest to the sun changes over a very long period. So there are times when, for instance, we would be closer to the sun during our summer, just not now.
So is that how we get El Niños and El Niñas?
No, El Niños and La Niñas are the result of the currents of water in the ocean. There's a very complex pattern of cold water going south from the pole going around the continents and then going back up north. And those shift with temperature, and like when one comes up higher, that causes very different weather than when the other one's up higher. And that's about all I know about, because not my area of expertise. Okay, so we've already talked about everything we need there. And we've already had that quiz question. Where the sun rises is always a little interesting. The sun is very, 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 very far away. And so for all intents and purposes, we will see the sun rising at the latitude that corresponds to where the ecliptic is at that time, where the sun is on the path of the ecliptic. So when the sun is as far north as it gets, we'll see the sun rise north of the equator. When the sun is south of the equator, we'll see it rise south. So we'll see the position of the sun move with respect to the, these are, rising these. So those are rising. So you see in the summer, it's rising north of the equator. In the winter, it's rising south of the equator. So in the summer, it rises north of the equator, but where does it pass us? Does it pass north of overhead or south of overhead? South. Remember I said it gets up to 16.5 degrees, but it doesn't ever get overhead. So the sun's going to rise looking north, right? So if you turn and look, get my direction straight. If you look straight east, in the middle of the summer, or even right now, you'll see the sun rising a little bit north of east. But then it will pass like that and set north of west. Once we get past September 22, if you were to do the same observation, you would see it rise south of east, go lower on the horizon, and set south of west. And of course, it's all because the Earth is rotating and where the sun is with respect to us. Now, I haven't talked about the tropics. I grew up in the tropics, well, until I was 5 and came to America. And so I always knew the term tropics. I knew we lived in the tropics, but I didn't know what it was. Does anybody know what it actually means to be in the tropics? What defines the tropics?
Isn't it between the 20th latitude or latitude north and south?
Not 20th, but close. It's the 23rd and a half, because the Earth is tilted 23.5 degrees. So the tropics, we have two tropics, the Tropic of Cancer and the Tropic of Capricorn. Those are defined as the latitudes that correspond to the northernmost point the sun reaches, so 23.5 degrees north, and the southernmost, 23.5 degrees south. The tropics is the region between those two tropic marks. And so you're in the tropics if you're between 23.5 degrees north and south. And if you're in the tropics, at some point during the year, the sun will pass directly over your head. If you're outside of the tropics, it'll never happen. Now that brings us to the Arctic Circle and the Antarctic Circle. The Arctic Circle and the Antarctic Circle are defined as the places where there will be at least one full 24-hour period where the sun never rises, and correspondingly one 24-hour period where the sun never sets. So because of the tilt, how far do you suppose it is from the North Pole to the extreme of the Arctic Circle? 23.5 degrees. So I told you that 23.5 degrees comes up a lot. Because of the Earth's tilt, we have a lot of things there that are affected. The Earth's precession, it takes about 26,000 years for the Earth to do one precession. Of course, the word precession probably means nothing to you, right? But you probably have, I don't know, if you grew up like me, you've played with tops, right? You spin a top. How many people have spun a top? I want to make sure, okay, so this is something people understand. When you spin a top, in a perfect world, it would just stay vertical and not move. Inception?
Yeah, the movie. They spin a top in Inception.
Huh. I have not watched it. And I don't feel bad about that. I have heard it's really, really crummy. I've heard that Walk to Remember is better than Inception. And there's only one movie worse than Walk to Remember, right? The Notebook.
I'm pretty sure Titanic is pretty bad too.
I could not stop laughing at the end of The Notebook. I was just laughing hysterically for like 5 minutes.
How are you laughing at that?
Because it's so ridiculously improbable. Now, A Walk to Remember has bad astronomy, right? In A Walk to Remember, they make a telescope. Well, he makes a telescope. It's really complicated to make a telescope so it actually is aligned right and you see a good picture. But hey, maybe he did it. Maybe he was really smooth. But then she comes up and she bumps it and you see the telescope move. And yet she looks in and she sees the comet. Like he made it aimed wrong so that when she bumped it, it would move to the right. Furthermore, it shows the comet going like this. You don't see comets move. You just see a nice blur there that's perfectly stationary as far as you can tell. Now, those really bad movies. The funny thing is, okay, so let's get back to this. You said Inception.
I like Interstellar a little better.
Oh my goodness, let's not talk about bad movies. Can we talk about Gravity if we're going to bring all the bad movies into play?
No, Gravity was a terrible movie.
So was Interstellar. Okay. Of course, these are opinions. They're not facts. I'm not trying to pretend I know all.
My grade hangs on the line now.
Okay, so you spin a top. The top doesn't just sit there vertical. It goes around like this, right? That motion like this is called precession. And it's, defined by physics. There is a further motion on that. It'll actually usually have little wiggly things on that precession. That's called nutation. We're not going to worry about nutation, but just so you know it exists. The Earth is spinning like a top, and because it's spinning like a top, it also will precess. But it takes about 26,000 years for it to go through one precession cycle. So it's not like we're going to sit here and say, oh yeah, I see the North Star moving around. But the North Star is not always the North Star. We just happen to be born at a lucky time when the Earth's north celestial pole points to the North Star. But over time, it's pointing to different locations. So, I believe I have the picture here. Yeah. This red line is indicating where the north celestial pole is over time. So here we are today. But you can see that, let's see, where's Vega? Here's Vega. About 14,000 years. That's CE, which stands for, and I have to explain this. CE stands for Common Era. What does Common Era stand for? It stands for AD. But what does AD stand for? It stands for Anno.
In the day of our, in the year.
Yeah, in the day of our Lord. It's Anno Domini, right?
Yeah.
The problem is people who are not Christians don't like to use Christ as a demarcation point. And so they don't want to use AD or BC. BC means very literally before Christ. And so they said, okay, instead of BC, let's say BCE. And instead of saying before Christ, mean before Common Era. So what does Common Era mean? It means the birth of Christ. And so BCE, before Common Era, before the birth of Christ. And then CE, Common Era, that's the time after the birth of Christ. So we normally say AD, but scientists are trying to move away from AD and BC because they don't want to invoke Christ. And that bothers me just a little, so that's why I explain it so you understand. Let it never be said that you can separate the religion from my classes. One of our Seventh-day Adventist institutions won in court that they were not pervasively sectarian, that you could separate the religion from the class. And so, like in a science class, there was no religion. And that way, they could receive government money to fund the science classes. I don't want anyone to ever believe that they could do that here. Got it? Okay. We are pervasively sectarian. That is, our religious beliefs are everywhere in our classes. Okay, I am going to skip past here because we've covered mostly everything here, and I'll start singing Sunrise, Sunset if I don't. The length of a year and a day. How long is a year?
365 and 66.
it turns out that 1 year is equal to 365.2422 mean solar days. Mean solar days. I have to define this. This is honestly, as far as I'm going to get for today's lecture. A mean means average. A solar day means from noon until noon. Noon being defined as the time when the sun crosses your meridian. The time from noon to noon varies every day. I had on the lecture last Wednesday, I had the analemma at the end. And the analemma, you saw motion that was going forward and backward, all taken at the same time, indicating that the sun's position is moving forward and backward as the earth is spinning. So the mean solar day is just saying over the course of a year, the average from noon to noon is 24 hours. So mean solar day is the 24 hours you're used to. Now, as the earth goes around the sun, we have a noon every time you are facing the sun. So let us suppose my nose is you and back of the classroom is the sun. So right now my nose is facing the back of the classroom, it'd be noon. And I go like this, and I come around, and I got to come a little bit more than one turn from my nose to face the back of the classroom because I moved. And I go around, I come again. Now I've done 2 full turns, but I have to keep going over to here from my nose to point. So I've done more than 2 turns to get to 2 days. Keep going around, Here it's 3, and so on. As I go around, if you actually count my turns, I will end up doing one more turn than, one more turn? Yeah. One more turn than I had noons. Because of me going around, well, okay, yeah, I said that. That's the problem. I have to go around the sun. The sun has to be something I'm going around. I didn't go around the back of the classroom. I made a mistake there. I have to use this. That's my reference point. Yeah, it would cancel out the way I did it because I wasn't thinking. So as the earth goes around the sun, if we have 365.2422 mean solar days, how many rotations did we do? It's one more rotation than it was solar days. So we have 366.2422 rotations in a year. Now, one rotation we call a sidereal day. Sidereal, if you look at it, looks like it's just saying side real. It means with respect to the stars. So 1 year is 366.2422 sidereal days. But only 365.2422 mean solar days. Which means the sidereal day can be calculated from the mean solar day just by taking our 24 hours and multiplying it by 365.2422 over 366.2422. And that gives you 23 hours, 50, I think it's 56, minutes, and 4.09 seconds. So a sidereal day, the time for one rotation, is slightly less than a mean solar day, 23 hours, 56 minutes, and 4.09 seconds. Remember we talked about the right ascension? Right ascension is essentially the same idea as longitude on Earth. The right ascension is measured in hours, minutes, and seconds, but it's measured in sidereal hours, minutes, seconds. Hence, you have only 23 hours, 56 minutes, and 4 seconds in right ascension, not 24 hours. Okay, I am out of time. Pick up here in lab mañana.